And I'm live. That is pretty cool. Today is 9th of August 2026, Thursday. And before beginning, a quote from Meditations by Marcus Aurelius, which is like pretty cool. Bust. This one, let's say. This one says, okay, it is about Socrates. This says, Socrates used to call the opinions of the many by the name of Lamine, Lamien, Lamiae. Okay, bugbears to frighten the children. Socrates used to call the opinions of the many by the name Lamian bugbears to frighten the children. So Socrates wanted children to be afraid of opinion of the masses, and that is why he called that by a weird name. So you should, because he didn't want children to get influenced by the popular opinion and question them. That was like his whole thing, question stuff. Cool. And now let's get into Docker. Yo, cool. Docker. We know about quite a lot of things at this point in Docker. That there are images, there are containers, volumes, networks, and we were trying to write our own Dockerfile. I did some research of this stream, and this seems to be we first.com. Why is this like? Okay, shit, there is a problem with my internet, but the upload is pretty cool. Shit, we saw that cool wallpaper change. It was pretty cool. Oh, cool. It's functioning. Cool. Boot.dev. Is there a problem with specifically boot.dev? No. Docker. Cool. And there might be a problem specifically with boot.dev. Yep. We want to write today Dockerfile to deploy something, and yep, to deploy something we can find out images, like for example in the this site that I wrote. In it there are three things: backend, the front end, and TUI, and some common stuff which are shared between the backend and the front end. This TUI is Go based, so we would like to have a image which has Go in it. So we can just go to hub.docker.com. Okay, cool, it is working now. Files, this would be the thing. Cool. Yep, Docker files, creating, dockerizing the server. Yep, we did this. Then creating an environment. Yep, this is the thing that we will do now. Before that, yep, for this thing, if you want to write a container for this TUI, which I have written, by the way, I'll show you how. This is written in Go. See, so we need a Linux image which uses Golang, which has Golang installed. So we can go to Golang's account on Docker Hub. Sign in. Golang's account on Docker Hub, and just like GitHub, they have uploaded different things, and one of those things, or like, yep, these are like all the things they have uploaded. And all of these are based. They have uploaded a base Trixie image which has Go installed, and Trixie is a Debian Linux. Bookworm, Alpine, all of these are Debian servers which have Go installed by default. So let's say we want to use this one, Go server for Trixie. We can have this, and we can define our own Dockerfile. Like here you are defining we want to write a Dockerfile from Debian. We can say we want from Golang, and the tag is this 1.26.2.trixie hyphen Trixie. We want this to use as the base image. Cool. And on this base image we will define our work directory. Our work directory would be slash bin slash app, let's say, or slash UI. That will be our work directory. And then we will git clone into this. We want to install git on this Trixie machine, and we do not expect git to be there by default. So install git on Golang Trixie. Sudo apt update sudo apt install git. Trixie Debian branch apt, but I do not think apt is there. Go with git with go. Shit, we can install git with go. Use go get this to download packages directly. Let's do this sudo apt. So we want to run a command there, or for which we have to say run go, not go, sudo apt in update, and then run sudo apt install git. Let's just see if we are able to download git and run git. That would be good enough. Git version. So this is defining that we want to make an image from a basic Golang image. Golang image is just a Trixie, which is Debian image, Linux Debian, which has Golang installed. And on that, we are saying that our work directory is going to be /bin /ty. In that, we want to run this command sudo apt update to update the package installer, and then to install git on it, and then run git version, not run cmd would be better. Yep, not just better, cmd is the way to go here. Git version. Cool. So now we can do docker build this thing, and what other things do we have to give? Let's see. Docker is not working right now. We have to start the Docker engine. Cool. It is alive. Docker help build. Help. Cool. And here tag to give the name. Docker build with tag, let's say git go, and tag would be latest, and from here. Cool. It is building allow. Cool. This is quite slow somehow. This is actually quite slow. Docker is the one which is using up all the space, all the bandwidth. This will just make an image. And that will be cached later on, so that we do not have to install the same thing again and again. But yep, about to be downloaded. It is downloading multiple things. All of this to download Golang Trixie. This is just part 1, Docker layer number 1. Okay, it is about to be installed or downloaded. Cool. Sudo run apt installed. Sudo not found. run apt install is the thing. Apt update docker build here. Cool. Run apt update. It is updating. Cool. We do have the image. Now we can do docker image ls to list all the things, and we do have this image. We can just run this. Okay, this is quite big. This image is actually quite big. Alpine 2.3. Alpine is much does not take as much memory, as much storage, but this one shared this image with Debian as the base OS is taking 1.33 GB, which is a lot. But let's make a container out of this image. Docker run container with the name, let's say go underscore git, and the image, and also build this in the background. Run this on the in the background with d flag go git, and image is this. Cool. Should we would not like to run this in the background because we want to see the log by git, and I guess we won't be able to run this because there is already a container with the name go git. Yep, cool. But now we do see git was installed. Pretty good. Now we can fix this docker file, and yep, now we have git installed. We would like to, after this, run git clone http /github.com/my name /ch. Cool. And then run cd /source/ty, then go cool, and then cmd./ty. So these run commands run when the image is being formed, and this cmd command runs when the container is forming. Hello, we are containerizing a ty which is written in Go. And hello, shit, your name is Tio. Tio is shit. Leo is cool, like Leo Tolstoy. Docker build tag would be git go latest, which would overwrite this image. Pretty good. This should work, or it should not. Shit. Git clone github.com process. This did not complete successfully. Exit code. Cloning could not read username for https://github.com GATIN. Okay, shit, I messed up in the Dockerfile, in the name here. RGHAV docker build tag git go. Cool, that should work, or it should not. Shit, go build output this main.go. Yes, this should work. Makes sense. We have to do npm install kind of stuff here. Run go mod id. I think that was the issue. Go.mod file not found in current directory. We did do cd. We did do cd here. run. Let's see where we are. Docker build. Okay. PWD does not print anything. Okay. Go mod tidy is giving error because there is no go.mod file. This should be a go.mod file or main.go file to go. Maybe we can build this without cding into the directory. Go run in no. Dockerfile, let's not do any of this. PWD should work as it is without echo. This CD should have taken us somewhere else. Source TUI. Let's do ls. Cool. ls. Docker build. ls does not print anything. cmd. Docker build. Cool. And Docker detached run shared. Docker image ls. Docker in detached mode run git go shit. Okay, D comes afterwards. Okay, do not run this in detached mode because we don't want to see the output of ls sch ech. Because that is the working directory where we did git clone. CD, this CD should be working. Go. Let's say echo echo the output of ls command. ls, put this into hello.txt. Right, do ls here and cat, if there is a file, cat hello.txt, but it might, we do not know where hello.txt is. So let's just do this for now and we will see where this hello.txt is to check why we are not able to cd into the correct folder. Docker run in detached mode. Yes, in detached mode. Run git go, okay, docker exec interactive tty into 706 fsh. Shit, it is not running because there is nothing to hold it in the running state. Yep, we are not able to cd. We are not able to cd. Look at this, because hello.txt is in the main folder. So we are not able to cd into the folder which has our source code. Which means this is not working. I guess we have to do cd and then go build. Output should be ty. Okay, I think that should work. Let's see. Docker build tag go git latest build here and possibly new error. Yep, now it is working. Now this is working. Pretty cool. Exporting layers. Everything is cached. Everything is cached except this last part. Docker PSA. Let's first of all see all this. Remove non running containers. Docker, all of them. How to remove all of them in one go. Prune. Shit, yes. Docker container prune. Docker container prune. Yes, cool. Docker PSA, nothing is working now. Docker run. Do not run this in the background. Wait, what are we even doing? Let's do cd into sh or run the file which is in sh ty. This should run our Docker container on port. Here we can see this file runs on port 22. We can forward this port onto some other port onto a local machine. Docker build this with this name. Say we will call this go ty building. Docker run in detached mode. Name of the container would be ty, and the image, before the image port, we want the port number, let's say 5236, just random port, to point to port number 22 in the container, and port number 22 in the container, on the container, and the image is go ty. That works. Now the container is running. Docker ps, it is running. Image is go ty and the name of the container is ty. And if we do ssh localhost port number, we gave it port number 5236. Yes, and it cool. The application is working. Cool. This thing is running in a Docker container. Pretty cool. Let's see, how can I put this image or shade? Now any of you watching the stream, you can copy this Docker file. You just need this Docker file and nothing else, and you need Docker installed on your machine. That is the only requirement, and then you can build an image out of this and run it. pretty cool. Let's actually do this on an AWS machine, which I have. You can also have it, like AWS gives you free credits, which is pretty cool. So SSH into admin@walrus.ports. This is the URL for the AWS machine which I have. This is the username, and as we do SSH to have control over that machine. And port number 4321. Is that enough? Nope. We also have to give in the key, because if this was enough, any one of you watching from the chat would be able to connect to the AWS server, which you do not own. It is mine to own, but yeah. So we also have a key which you have to give, and the key is inside documents vps/secret pem.walrus. Cool. And I am in. Right now I am in the AWS server. Here we do not have Docker installed. Install Docker on. Is the machine Ubuntu? Yep. No, Debian. This is a Debian machine. Debian AWS machine. Install Docker engine. That is a remove old version. We do not have an old version. Docker desktop. No. Run the following command to uninstall all conflicting packages. Setup. Okay, that is a expensive process. It feels like that is a lot of stuff to do. Latest. Okay. Sudo apt install docker ce cli container.io docker build x plugin doc. Okay, we are installing quite a lot of things. Shit. Set up apt's repository. Okay, then second command, install all this. Shit. Installing Docker should not be difficult. That is the one thing that Docker is used for, to make installing things easier. Okay, let's follow this properly. Prerequisites. Firewall, no. Deventrixy. Okay, let's do this to remove anything we might have, but yep, we do not have anything installed beforehand because this is a random machine. Installation methods. You can install Docker engine in different ways depending on your needs. Docker engine comes bundled with, we do not need Docker desktop. Setup and install Docker engine from Docker's apt repository. That's what we need. And the other options are install manually, convenience script. Let's use a convenience script. Cool. Should work. Wait, that was very quick. Okay, we are installing Docker. We are installing Docker not locally but on the remote AWS machine, and that machine is in Mumbai. Peace out. Shit, I'm not logged in. Let me log in. I don't guess there is any problem in showing this. Because this takes fingerprint. to install. So even if you knew the password, you wouldn't be able to log in. And yep, this is the AWS machine which is running right now. EC3 micro. This is running in AP South. AP means Asia Pacific South. This is the IP address and stuff. Cool. To run Docker as non-privileged user, consider setting up this. Is it this? Okay, we might have Docker installed now. Docker H. Yes, Docker is installed. Now we would like to run our TUI on this Docker in using a Docker container. We can, like, I guess, write the file again. Dockerfile. Make dir docker cd. And I have nvim. Shit, I don't think I have nvim here. Shit, I do have nvim here. And the name of the file would be Dockerfile with capital D. From GitHub. Just shit, what is this? 8,900 minus, we have to answer this before we can access the terminal. That is how this thing works. 8,900 minus 180 plus 2. 8,800, 8,722. Probably. Cool. Okay, it was ls. We need this Docker file in our remote AWS machine, or we could just like copy paste this. Read this. Workdir /bin/ty to tell it what is our main working directory. Then run update, and then run apt install git to install git, and then run git clone https://github.com/jatin raghav/sh which is sha, which is chess in German. And then run cd sh, go into the folder source ty and go build with the output name ty, and when the container starts, run this command /sh/source/ty/ty. That should work. Docker build with tag ty latest. Permission denied is crazy. Sudo docker build ty latest. Cool. And this will take some time because it has to install a big image. Hello Roxu, long time no see. How is it going? How are you? Here we are building Docker images, which is like pretty cool. Shit. API. Enum Dockerfile. apt, of course, yes. Apt update, and then apt install git clone, the right repository. The name is also correct. github.com/jatin rghv source ty go build here. Cool. And instead of Trixie, we should use Alpine, which is much more lightweight. I'm resting all day, feeling weak. Yes, rest is cool, right? And where are you right now? Are you back from Japan? And do you know about Docker? Docker is pretty cool. sudo docker build tag dy latest here, and you will get pretty strong. You are very young and you will get stronger. And shit, maybe you might be able to defeat me in arm wrestling. You will have to see. You will have to see. For that, you will have to come here. Whenever you come in India, just message me on Discord or come on the stream and we will have a fist fight. You'll see. Arm wrestling. Wait, what is a lightweight alpine build? Lightweight alpine build is here. Just like GitHub, we have Dockerhub, which has images. GitHub has code uploaded by people. Like this is my GitHub account, and in repositories, we have all the code bases uploaded by me. On Dockerhub, you upload images, and images are like operating systems, mini operating systems, which Docker can read and run. And this is, there are multiple images provided by Go, and Go images, there is a, either you could, just like there are different versions of Linux, you could have Debian, you could have Alpine is also Linux, Arch Linux, Omarchy, NixOS, there are different Linux distributions. Similarly, Go provides you Linux with Go installed on top of them. On top of the base Linux, Go provides you Linux which have Go installed on them, and that base Linux can be different. It could use Trixie. Trixie is latest Debian Linux. Debian names its versions, like it does not name different versions as Debian 1, Debian 2, Debian 3. It names them like this, like Debian Trixie, Debian this or that. The only one that I know of is Trixie. Trixie is the latest one. And similarly, there are different Linux base images. There's a Alpine one, which is very small build. Trixie is more than 1 GB in size, but Alpine is, I think, 300 or 400 MB. We can see Alpine. Okay, 93 MB. It is very small, and it also has Go installed, so pretty cool. Yeah. Hey, shit, you are still in Japan. Okay, you are. Yes, there is emotional support, or maybe you can get emotional support from the vending machine. There is everything in the vending machine there. I used Docker earlier. I used Kali Linux. Shit, you used Kali Linux in Docker. That is crazy. You can check out Qemu. It is pretty cool. And we have our image built here. Docker also uses QEMU under the hood. You can use this to run crazy stuff. And let me show you one thing which is very cool. I have QEMU installed. QEMU. I have, just believe me. And I have a script, run vm.sh. And if I run .nix, this will boot up a Nginx virtual machine which I have installed. This is booting. This is booting. This is booting. Look at this. Look at this. Username walrus. Password is password. And this uses Sway. And this is like a whole ass Linux machine working inside Mac OS. Pretty cool. But this thing does not have mouse support yet. I do not know how to enable mouse support, so I just cannot use mouse. This, you are seeing mouse right now because it is not in the VM, it is outside the VM. And when I click anywhere, just the mouse support goes away. So pretty cool. That is like pretty cool. And to shut off this virtual machine, you do sudo shutdown h now, and then your password, and yep, this thing goes away. Pretty cool. Virtual machines are pretty cool. I'm like so weak that I'm barely solving. Hey, shit, like take it easy, or do whatever you like it is up to you. If you want to solve problems, that is cool. If you want to take a rest, that is cool. Do whatever you like, and maybe watch pretty cool movies. No, I do not daily drive Nix. I came to know about Nix some time ago, like 1 or 2 weeks ago. And I want to build my configuration so that when I do go to a Intel machine, I can just pull up that configuration and work with it. To do pretty cool. Okay, so the Docker image is built. Docker image ls shit sudo. We have to run all these commands with sudo, or we can just switch to the root user, which is much better. Docker image ls. We have one image, ty image, docker, and look at this, the size 1.56 GB. That is very big. Docker run name for this would be ty, and ty is the image name. And shit, this is running not in the background but in the foreground. So yep, docker esa docker remove ty docker run in the background. D means detached, run in the background. This took up our terminal control here, so now we are running it in the background. Name for this container would be ty, and image is ty, so it is running now. Docker yes, but we cannot connect to this because we do not have any access to this thing. So to connect to this, we have to do doc. First of all, we will remove this. Docker kill ty, docker remove ty, and then docker run in detached mode. Name would be ty, and give access. Connect the port in host machine, port number let's say 69420, with port number 22 in the container, and name of the image is shit, invalid port is like, I guess, too big. 6920 seems good enough. Cool, so now it is working. And if we do this is it, local host 6920, yes, shit, requires an active pty. Okay, the ty cannot run on this external AWS machine because this does not have a pty. Pty is a sudo terminal because sudo starts from p, so p, ty is terminal y, and we do not have a pty. What we have is a tty, which is, what is the full form of tty? Teletyper. We have a tty which does not have support for showing complex stuff on the screen. Let's stop this. Kill ty, docker remove ui, exit. This is it, walrus.codes. Yeah, like we get the point, it is working. Wait, previously I used to give a walk every evening. Now I can be, hey, shit, it is, I do not want to say that it is getting bad, but hey, fully it will get better. Just to sleep and wake up, takes meds and solve some problems. Okay, you are still solving problems, that is crazy. Like, keep doing it, you will get better, I hope. My mom, everything, and she accepted, which, yeah, keep smiling also, like smile, keep smiling. Yeah, you will be cool. You are like holding up pretty good. You are solving lead code problems. Here I am not solving code forces problems every day, even though I am healthy, and you are solving problems every day. That is pretty cool. PTY versus TTY. Yep. TTY is very basic. It just shows you text and no fancy things. And this thing here, you might have a terminal. My terminal is ghosty terminal, and it is not a actual terminal, it is a pseudo terminal, because in a actual terminal you just see text, you do not see icons. Like look at this, you have the Docker icon, you do not see these things. In a TTY you just see normal text, but a PTY is a pseudo terminal. It is not an actual terminal, but it is acting like a terminal. Yeah, and it has more features. Cool. Let's start on with this. Dev, Docker, creating an environment. How do we create an environment in a Docker container or image? You may think, what is the point of Dockerizing this simple server? Well, at the moment, there are only a couple of benefits. Green is not stuck. Anyone with Docker can run your image. Pretty cool. Regardless of their OS, they just need Docker. You can easily deploy containers of your image on any cloud service that uses image, most of them, or on an orchestration server like Kubernetes. Kubernetes is more complex. I don't know how to use Kubernetes. It is like much more complex than Docker, but it helps you load balance, or it spins up more servers whenever there is need, and destroy server when a lot of people are not going to your website. So pretty cool. Kubernetes is cool, and we will read about Kubernetes when we have done Docker. That would be cool. Okay, if your server were written in a language like Python or JavaScript, you could bundle the interpreter and dependencies inside the image so that you don't need to reconfigure them on the server. I really like Docker because with Docker, you just have to define your Docker image only once, and if your friend has Docker installed, they will be able to run your server, which is pretty cool. Pretty cool. Some food and brings me to eat is shared. It is Japanese people can be very nice. Old people, old Japanese people can be nice. I don't know them in real life, but from anime, they seem very nice. Yep, that is very nice of her. That's it. Docker. That's it. Because our app is so simple, there's just not much environment required. Okay, and one of the best things about Docker is that it allows you to ship an entire environment. Yep, you are like shipping an actual operating system along with your code base. So let's make it more interesting. And the thing about environments, it's pretty cool. And why this shell that you are seeing right now, when you do ls is a command, right? And whenever you enter something and press you type something out and press enter, this thing goes to a engine, which is like your shell engine. Just like JavaScript has its engine, this thing has its engine, bash engine, or I'm using ZSH. You can do this to see what you are running. I'm running ZSH. So this, like how to interpret these two characters ls, is handled by this program, ZSH program. And this is similar to if you were to type node and then do a equals 5 console.log a, you see file, exit. Shit, how do we, how I can press Control C, but dot exit. Okay, cool. Dot exit. So yep, this is very similar to this. Not just very similar, it is, I think, the exact same thing. When you write commands in your shell or inside a node environment, these two are exactly the same thing. And when we mean when we say environment variables, we just mean the very, like here we defined a equals 5. That is the exact thing when we say environment variables. So if you were say for JavaScript, the syntax is console.log a to see the value of a, and in shell the syntax is echo prints whatever is on its right, and $a is used to not use a as a string but use a as a variable. So this will print whatever the value is for a variable a. A is not defined, so we don't see anything. But if we were to say a equals hello there and then dollar echo a, we see a has a value hello there, and that is the environment variable. And here they are saying port equals os dot get env. This is the function given to us by Go engine to get some environment variable. So go init shit go mod init shit go mod init. Here this is the shit go mod init hello. Yes, cool. Main.go package main func main side our main function. Let's get value equals os dot get env. Yep, get env, get the value of a, the variable that we defined, shit declared but not used, and undefined get env. Okay, g has to be capital. E has to be small. Okay, and then fmt dot print value, print ln to give a new line at the end. Cool. So this should print the value of e of variable a which we defined just now, which was equal to hello world. So go run this. Okay, a is not defined. I guess why is a is defined in the shell? Why do we not get its value inside this thing? Get env, get env. Change port to this. If we do hello equals world echo hello, hello has the value world, and here we want to get the value of this thing. Go run this. Okay, go build ls dot slash hello. That is crazy. That should not be the case. I could course error with a project I deploy on my EC2 instance. What can be a solution? Okay, by default, if you are running Express application or something, your backend, which is listening for incoming requests, it stops. It only takes in requests from the servers that you have listed explicitly, and whatever library you are using, you have to tell that library what are the valid addresses from which I am going to take in requests and give out a response. And if you are using Express, then the way how you do it is, yep, you tell it like this. Allow request from this domain or whatever, or there is an option to allow requests from any domain. I think that is what most people use, allow request from any domain, and that is pretty cool. Very polite and simple people. No, you are not disturbing. Like, if this makes you feel better, I can do this full day. I will just like listen to you speaking stuff. If it makes you feel better, it is shit. I think I pressed undo. Okay, I messed up. No, you are not disturbing. Whatever you want to say, you can just say. Also, your Vim skills are good. Can you try teach Vim from? Okay, you need first of all the theory. And I'm sorry for deleting your messages by mistake. It is not some subconscious thing happening. And yep, write whatever you want to. I am here. I will be reading everything. And for Vim, you need theoretical knowledge of what Vim is, how it works, and everything about Vim. Not everything, but as much as you can get. There is one very good place, Viro and Vim. You can watch this series. This is pretty cool. There are just 12 videos in this, and this is actually pretty cool. That is the least I can do, literally. Check out this playlist for understanding NeoVim. It is in the name, Understanding NeoVim, by this guy Viro. He's pretty cool. He explains what is NeoVim, what are plugins, bugs, tree sitter, what is a tree sitter, and then he goes on to LSP, how to manually set up an LSP. That's how I set up an LSP, and how to use Mason, and then completion engine, lazy dev, keybinds. I've not watched these two videos, but yeah. This for theoretical knowledge to write your own NeoVim config, and this might take a few, at least a month, I think, to understand, because you will be learning about what is a tree sitter. If you do not know these things, if these are very new to you, it will take some time, but it is cool. That is how things work. Tree sitter, LSP, Tame Impala. And so this is for theoretical knowledge. And Vim, what is Vim? Okay, Vim Texas. Vim Primogen. Go watch few videos from here. Like what are some shortcuts things in Vim, and then just practice. Yep. And write your own config. That would be cool. Just that. Cool. And now back to this. The problem was we have defined a variable. Legit, we have defined a variable, hello, which has the value world, but it is invisible to this our Go program. Why is that? Let's see. So I think because it might be because this is a binary, but I think Go does ship with along with the binary the garbage collector which runs with it. If you were to see ls lh hello, the size of this thing, this is 2.4 MBs. This single program which just takes a simple variable and prints its value, this is 2.4 MBs. And why? Because the whole garbage collector is in this binary. And my suspicion is that not just the garbage collector, but the whole environment of Go is there with this, and that environment is different from this environment where we have defined this hello variable. That is just a suspicion. Let's check. When os.get env var in Go or get the value for var from the shell in which it is running. So, and if I were to do var equals I and then run the Go binary, will I get the value for this var? And the answer is that we do not get the value for this var. We need to understand why we don't get that. No, I did not learn Crow. Are you using Git CI? Wait, Git CI to build or local? Right now I'm like on local. I don't understand what you mean by this. CI, yes. Git CI, I have a Git CI set up for one of this project, one of my projects. This one, this doesn't do much. This is just for the backend. This deploys the backend, gets SSHs into the machine and gets the latest code and restarts the PM2 server. And same for the TY. No, no, I've not learned Crow. No, I deployed on my college server, but getting errors on AWS because of course you have to allow different addresses to reach there, or there is also it might be the firewall on your AWS server. It might be the firewall on your AWS server, which is making that specific port on which your backend is running invisible to the outside world, or inaccessible, not invisible. I would be helpful on Linux, but I don't know how Mac and Windows do it. Wait, GitHub CI is used for, well, CI specifically, continuous integration, is used for, but you are saying Git, not GitHub. I will assume GitHub CI. GitHub CI is used for testing out stuff, for checking linting or everything except deployment, and not for build. If you want to build, okay, it can also be used for building, to check whether the commit which was just made by this user, does it even build or not. Good. And is it nice to practice? Nice practice to take help of AI if getting stuck. Yes, of course. And do not use AI unless you do not understand what it is doing. Like here, I am not able to understand something. So use AI as a teacher, as if you have a senior OS dev sitting with you and you are just asking that dev some problems which you do not understand. Check the firewall, allow 5000 port and 80 for front end. Okay. Yes, I am building Dockerfile. Okay, I'm learning about Dockerfile here. And after Dockerfiles, it would be debug and then publish, which would, I guess publish would be about publishing your images. npm run CI. What is CI package? Shit. Wait, is this the thing that you're referring to? Wait, npm run CI. CI is going to be a script which would be self-defined. And it can be anything depending on what you write in that script. Okay, okay, it might be that maybe, I mean, what would I know? Maybe you are confusing CI as a program. CI is just a script that you tell npm to run whenever you do npm run CI. It is not a tool or anything. Okay, yep. And like I might of course be wrong. Like your what keep going. Okay, thank you for that. Deadly 6969, cool name. Dockerfile, this is the Dockerfile. Here we get a very big Trixie image, which is like very big. And then we make our work directory, we run update for the package manager, git clone, we get the code, we go into the right place and There we build, and when the container runs, we run the binary that we got. So pretty cool. And cool about the environment variable thing. Yes, get var reads from the process's environment, which is inherited from the shell that launched it. Okay, they both of them do have a different environment, but it is like a fork. Your main shell has an environment like this one here. This has an environment, and it is copied, inherited, or cloned by the Go process, which means the Go process will be able to see all the environment, should be able to see all the environment variables which were here. But if Go creates a new environment variable, that would not be visible when the Go program ends. It would not be visible here by the outside because we are not making change to the same thing. It is like passing by value and not by reference. Yeah, Dockerfile is working. It is pretty cool. It's just not, we are unable to get some environment variables somehow. Yes, that is a problem. Export, we have to do export. With export, okay, that was the problem. If we do var equals high, that variable is only visible to the process that is running. But if we do export, that variable will be visible by all the child process. This makes so much sense. So the variable that we are trying to get is hello. If we do instead, before we did hello equals world, but export hello equals world, and now if we run /hello, okay, cool, we are able to get that environment variable here. Cool. Yep, work there is there. Hello Dockerfile right here. Work is there, and these are the other commands, and pretty cool. And this highlighting that you see right now is also pretty cool. You have to install the tree sitter, the LSP, and there are like 3 different LSPs for Docker. There is a old one for Dockerfile. There is a LSP for Docker LS for Docker compose files, and there is a new LSP which does not seem to be doing a lot. Wait, and inspect tree. This is the tree sitter for this, and this is like also for you, Deadly69. You want to learn Vim. Wait. LSP config. Yep, there are like 3 different LSPs for Docker. Docker Compose language service. Shit. Server, I think. We can check it right here. Help. LSP config all and Docker. Okay, it is service, not server. It is service. Language service, and there is Docker language server, and then there is Docker ls. Madness. Cool. And yep. Back to that. We haven't even done one thing here. Cool. Export. Yep, cool. So they are just saying like what we did here, and the same thing in Go. This is the syntax for getting an environment variable. And from our main shell, if we do this port, it will create a variable named port whose value would be this, which we will get inside our Go program like this. Then we build and run it. But in our Docker env file, we can make stuff in our Docker file itself. So instead of doing installing Git, we will copy the, not everything, we, yes, let's say everything, we will copy everything from the host machine's current folder to the Docker machine's work there, and there run go build this, and then dot slash also give oh hello and cool hello, and let's see, Docker image ls. These are the images which we have, and I would like to delete some of them, they are taking a lot of space. Docker build tag would be env latest, and here cool and Docker run env. Anything else? No. Cool. Let's give it a name. Name would be env, and the name of the image is env, and we do not see anything. Why? Because that variable hello does not exist inside in the environment of this container, which we can define with this command env. Create an environment variable hello whose value is world, and Docker build env Docker run. Should we have to delete the older one first? Docker remove env shit env Docker run, name is env, image name is env, and world does exist there. So we have replaced the part where we did export hello equals world with this env environment variable hello has the value world. Pretty cool. Docker PSA, there are two containers running. Docker remove env Docker remove UI. UI is running that. Docker kill UI. Docker remove UI. Docker image ls. Docker image ls. Docker image remove, and then the name of the image. Let's say caddy, that removed the caddy image, or there is a shorthand RMI to remove an image directly. Git go and go git go UI and go server. And GOT git, it does not exist, it makes sense, a typo. Docker RMI env go git and Docker getting started. Docker image ls, nothing. Cool. We can consider this one done. Python script. See, hello water, and look at this, water is a member. Like cool, you also have walrus. Like what are you aiming to do? Run a container with compose. The aim is just to like spend some time with Docker and understand it, so that I can use compose. And compose, as I have heard, is only used for development at the time of development, but not for deployment. In deployment, you actually manually do the whole thing. That is what I have heard. Hello water. If you are free, can you watch this movie? Incendies 2010 by Denis Villeneuve, and shit, this movie is crazy. I won't say much, but yep, this movie is crazy. I watched this movie, War and Mystery Indeed. this will like destroy you. This will break you apart into pieces. So if you are up for that, check this out. Incendies. Okay, cool. And what do we want? We have seen how simple it is to Dockerize Go programs. That is part of the beauty of Go. The machine or Docker image running the program doesn't need the Go compiler installed. None of the following images are easily deployed in the same in the same way. Okay, they all have runtime dependencies. To show what I mean, let's dockerize a little Python script. Okay, so they are saying it was easy to containerize this Go program because of Go, but it is very difficult for all these rest of the things. They all have runtime dependencies. To show you what I mean, let's dockerize. Okay, let's dockerize. Copy the Python code at the bottom of this page and add it in a main.py file in your project directory. This Python code, okay, little bit more than hello world, and then copy the Frankenstein text from here in your repository. Okay, at this place. Okay, let's do this. Okay, dir docker python cd docker python and main.py. Yep, the error was there because this file was not saved. Now it is saved, and copy this text. We have to copy this text, control C, shade, and here. Okay, new is stuck. New is actually stuck. Somehow I broke something up. Okay, let's go. OTT. I mean, I did pirate, but maybe this might be on OTT. This should be on OTT, ideally. Incendies. 813 rating, pretty high. And you will know, he is the same guy who made Prisoners, who made Blade Runner 1949, and made Dune Part 1, Part 2, and is now making Part 3. Yep. And he is also French. And he also made a movie called Polytechnique. He also made Sicario. Sicario was cool. He also made Arrival, which was cool. Where is Polytechnique? Polytechnique. He also made Polytechnique. He's a pretty cool director. And yep, by the way, this movie is in French. So you'll have to turn on subtitles, French and Arabic. But yeah, this must be on somewhere. Prime Video, it is on Prime Video. You can watch it on Prime Video. It is on Netflix. Cool. Or you can just pirate. Here, book or books. Books. And here, Frankenstein.txt. Frankenstein is also a pretty cool book. Frankenstein. .txt. Paste, not this. This. Project Gutenberg. Okay, and the steps. We did this. Now make sure you have Python 3.1 installed locally. Okay, we do have Python 3 installed. I mean, I do have. Share. Yes, Python 3.14. Shit, 3.1. Okay, Py. You can short Python to Py and then 3.14. That is like pretty funny, I guess. Py is 3.14. Very cool joke. Yes, we do have it installed. And then make sure the program works. You should get a nice little report. Okay. Python 3 main.py. Okay, to count words. Cool, and that was the whole assignment. Okay, let's dockerize this whole thing without reading on how they do it. Dockerizing Python error. We will make this thing on our own Dockerfile. In Dockerfile, we will go to hub.docker.com, not any other hub, Docker hub, and here we are looking for a Linux machine which has Python. While there's two Pythons, this one has 1 billion downloads. This one just have 10 million. I guess this is the official one. And let's use a simple Python one. Alpine is the one because it is smaller, does not take a lot of space. 16 MBs is crazy. So here we'll say from, okay, my phone is going to die. And Dockerfile is very cool because this kind of tests how much you know about computers. So to run your Python script, first of all, you need an operating system which has Python, which we can get from Docker Hub, saying Python, from Python username, we want this. Cool. Failed. Okay, cool. We now have the operating system which has Python. Then we will define a work directory. Let's say /app. App. Now we have a working directory. Copy to get our main.py file here. And wait, main.py file and books directory. And why is this cache here? Let's delete this so that we only have books and main.py and nothing else. And then what do we want to do? Python run pip install. Are we using some dependencies for this? No, there is no import. So cool. We can then just do Python main.py. This should just work. So you got a operating system, then you defined where you want to do all the things, and then you got the code, and then you like run the code. Docker build here tag tag is pp latest. This is downloading the operating system. And docker run ppp with name pp. Shit. Error response from human. Failed to create task for container. Failed to create shim task ocdi runtime. Docker run name pp. Okay, it works. And we got error because I gave the name of the image first and then the name of the container. The name of the image has to be the last parameter. But shit, there is like no problem with this. It is working fine. So what are the is the thing that they were so scared of here? Okay, because they are using a base image, base Linux image which does not have Python or anything. Cool. Let's dockerize the Python script. So, yep. This thing does not have Python. and this will give us error because there is no Python. Build the image, be sure to specify the Dockerfile name. Yep, and this thing just gets a basic Debian operating system, copies the main thing, copies the books directory and tries to run Python, but this will give error because Python does not exist on this base image. And then we try to run this and aha, error. Of course, we will get error because Python does not exist. Now Dockerizing Python. Yep, this gave us error. And then okay, so our first attempt at Dockerizing the Python script didn't work. Let's fix it. The problem is our image doesn't have the Python interpreter installed, so it cannot run the script. Yes, that is true. Update dockerfile.py to run the command to install the necessary dependencies before the script is started. If you are up for the challenge, figure out how to install Python on your own. If not, I have included the Dockerfile below in the tip. Yep, like we just have to run a command which installs Python on a Debian machine. We can look it up, Google it up. We don't have to remember it. That would be crazy if someone remembers how to download Python. Shit, update the apt package here. Install Python building tool. Okay, shit, these all things are required for building Python. And then we install Python, build the Python interpreter. We did all this code to install Python. We could either do this or take a base image which has Python installed already. Pretty cool. And this would work now because we would have Python here. Debug. Let's see what is in debug. Docker logs when containers are running in detached mode with D. You don't see any. Yes, we don't see anything, but I guess we can just do, yep, this Docker logs name of the container to see the logs by a container. So if we were to run this app in detached mode, is a Docker remove by force pp Docker remove by force. F9 F1 Docker PSA, nothing is working. Yep, nothing is running. Docker run in detached mode. Run name is pp. ppp is the name of the image. Now we didn't see any logs. If you want to see the logs, we can do docker logs 90fe or pp, and we do see the logs. Cool. That is the same thing they are saying here. To see the logs, you just do docker logs name of the container and some options if you want to give them. Logs, tail. Cool. Different ways to see the logs. Stats. Okay, stats, that is a new thing. What is this? Okay, we know how to inspect a container's logs, but what if we want to see the resource utilization? Yes, yes. And this guy is named Lane Wagner. He is the one who created this website. It is common to spin up some Docker containers, forget about them, and then wonder why is your host machine has gotten really slow. It is really nice to see how much RAM CPU each container is using, and it is critical in production environments. Okay, okay. The Docker stats command gives you, okay, okay. We run some stuff. The pre-build is stress ng image is a nice little image that we can use to create a container that artificially uses a lot of CPU / memory usage. Start a container that uses a full CPU core. This, okay, this command reads Docker, like main thing, run a container in detached mode. The name of the container would be CPU stress, and what is this? This is like the second name. This will use 2 CPU cores, timeout. Okay, this is not the second name. This is the image. The image is at this URL, and this uses 2 CPU cores. I think that is what this CPU means. And this thing is stop this container after 10 minutes. This is going to slow down your machine somewhat while it is running, but don't worry, we will kill it soon. Yep. And we add a 10-minute timeout just in case you forget to kill it later. Okay, just copy this and we'll write the rest of the thing on our own. Docker clear, docker run, name a CPU, press, this is the image, CPU 2, timeout 10M, 10M, and unable to find image locally. Install the image or pull the image. Yep, it is pulling the image. And shit, this is not running in detached mode. I should have said detached, but this is not detached. Shit, I messed up. Let's stop this. Docker remove CPU, press docker also remove pp, docker run in detached mode, name CPU, press. This is the place from where we get the image. Okay, docker stats to see the stats, docker stats, help. These are the things. Docker stats, name of the container, and options. Aliases, there are aliases also for this. And options, all, show all containers, default, format output, like this. Docker stats, we want to see the stats for CPU, press this container, and this is using like 200% of the CPU, which we can see here. Docker is using 200% of the CPU, and it is 200% because there are multiple cores. Cool. Now start another that uses a lot of memory, 1 GB of memory. Stress ng. Cool. So it just means that we can use Docker stats to look at some stats about the VM that is running. Docker PSA and Docker RM. Shit, it is still working. So first we have to kill this thing, or we can do RM force CPU stress. And no container is working right now. Top, Docker top does something. Let's see. Docker top display the running processes of a container, like run top inside a container makes sense. Top for processes in the container, like cool. This is, we know what top command does. It shows us all the processes which are running right now, and top with a container name shows us the processes running inside a container. And here the top command is used for processes. Resource of an unladen African swallow, that is certainly not the answer. Resource usage of processes inside a container. Resource usage, nope. Resource usage of the container itself, nope. This third would be the correct answer. Resource usage of process inside a container, processes inside a container, and the stats is for resource usage of the container itself. And now the last one here, resource limits. What is this? When you notice a container using too many resources, if you don't have the time or ability to fix the code, you can limit the resources the container has available. The docker run command has a few options for limiting resources. We can limit the memory, we can limit the CPU. Docker CPUs 0.25, okay, just use 0.25 of the CPU. Name this thing And the same with memory, we can limit how much memory we are giving to a container. Cool, like, yes, it makes sense. We don't need to do anything special. We can limit the memory, we can limit the CPU we are giving to the container, we can check out logs, we can see stats, we can see what processes are running. Now the last thing, Docker publish something to Docker Hub. And what we will do in this is we will publish the Go image, the Go TUI. Let's see. You should have already created a Docker Hub. Yep, we have, but let's review a bit about what Docker Hub is. Docker Hub is the official cloud service for storing and sharing Docker images. We call these kinds of service registries. Other popular ones are AWS ECR, Elastic Container Registry, GCP, Google Cloud Provider, Google Container Provider, GitHub Container Registry, Harbor, Azure. Assignment is navigate to the caddy namespace on Docker Hub. Notice that it has two public repositories. Click into each to check them out and answer the question. Okay, let's see what is in caddy. Okay, these are images. How do you look for users? Just like the same way that when, okay, let's go to this image. Can be hardened image. Caddy. Okay, don't we have the concept of a user uploading images? And we do have a concept of user uploading images, but who is the user? Caddy. Cool. Caddy user has two repositories, caddy ingress. Okay, 10 million downloads, 50k downloads for this. Caddy. This thing, this repository is for CI only to support the official image. 1.9 GB size, that is quite a lot of size. Okay, and the question here was, how does Docker Hub organize images in repositories, which we cannot answer because but okay, in repositories which contain different containers of the same tag name. How does Docker Hub organize images? We have inside Docker Hub, we have users who have different repositories, and you could call them repositories, and one repository has one image, but you could have multiple in the same repository which are differentiated by the tag, though the repository name would be same. Repositories which contain different containers, not containers with the same tag name, but images in repositories that contain different tags / versions of the same image name. Yes, that seems like correct. In containers which contain different images of the same tag name. No, different images differ based on the tag. In buzzwords which contain different DevOps of the same machine learning name. This one, in repositories that contain different tag versions of the same image name. And then publish. How do we publish? Let's publish the Go server we dockerized up to Docker Hub. Okay. Build something, username, and this rebuild the image. We'll write our username and this, run your image in the container to make sure it still works. Just check, then push this up to Docker Hub. Okay, my account is here. My hub is a thing, and this thing does not have anything. Hardened images. Okay, there is nothing here right now, so let's create something. Mm, not Python. Let's have a very simple basic C++ thing. Shit. And there might be an image for C++ or CPP. Uh, 10,000, 10 years old Dockerfile is here. Let's see. Provisions shares the scale and development environments without the need for manual configuration using Docker and without use our pre-built environment and store here Docker of C++ based on this G++ installed. I think we can manually also install C++. It is like not too difficult. Okay, let's get a simple image, Go server, simple or JavaScript. Types or node, shit, yes, node or bun. Yes, we need a bun server. Just bun, but there are no tags after this. So these are all the images. Yep, this one we will be using this one. This is based on Alpine. Looks good. cd bun server Dockerfile. Tags. Yep. Bun has Alpine. Failed to parse name, invalid name, images. Okay, we want this image. What should be the name of this image? Docker bun image hub.docker.com oven this bun latest. Bun is fast. Okay, canary Alpine. If you want to get the Alpine version, what do we say? Alpine. From oven /bun Alpine tag. Okay, that should give us the base image. Then copy everything from here back to here, and also like work there is slash app and run. Install, copy package.json to package.json and copy package.log json package.log json, then do one install and then copy everything else, then one index.ts run or cmd. One index.ts. Cool. That should work. We just have to do one init blank index.ts console.log via one. Cool. That should just work. Docker build tag is one project, tag is latest. Here, that should work. And like shit, package log.json is not here. Makes sense. We can just remove this file. And while this is happening, I will go to the washroom and I will be right back in 1 minute. Just 1 minute. Cool, and I'm back, and there's been one person watching this boring stream the whole time, and thank you for that. I guess you might be water. I'm just like speculating. Cool. We have the image built, but shit, we gave it the wrong name. The name is the prime agent, but the name should have been, yep, username, my username on Docker Hub, which is my username, Datanaga137. Shit. So I guess we just change it. 137 go server, or not go, this is TypeScript TSS TypeScript server. Cool. And just go push 137 TSS. Shit, not go push, Docker push /TSS. Okay, waiting. This should just push this image so that anyone can use it. What we will do after this is I will launch up the VM which I have, and in that VM we will pull this image, but we will also have to install Docker on that VM, and that VM is using Nginx OS, which is more difficult. We will just cd into the AWS server, we will pull this image on the AWS remote server and run this there. It is somehow taking quite long because of upload. Upload is slow. My hub. This would have create some repository here, language specific guides. Shit, they have Docker guides, which makes sense. Like, yep, you would have Docker guides. Cool, they have like courses, articles. Cool. Docker.io. Almost there. And okay, pushed. Cool. Shit. If we refresh, we do see that there is this server. Pretty good. Let's SSH documents VPS secret key SSH into admin @walrus dot codes with port 402. Cool. Here we do have Docker version. Cool. cd docker pull GETINRAGHEV 137 /tss. Shit, permission denied. To connect to the Docker socket. Docker server is not running. How to start and stop Docker server on Linux from the command line. Permission denied. Ah, shit. Sudo. It is a permission denied error. Docker pull JADINRAGHAV 137 /tss. Cool. We are getting the image. We are not getting it. No matching manifest found for this specific architecture, Linux AMD 64. So we want to create image for multiple architectures. And push them to Docker Hub. How do we do this? The problem is the image was made on macOS with ARM architecture, but this AWS machine has Linux and has AMD architecture. Docker build x create. Or we can write this in the Dockerfile itself. Step 1. Okay, build x is the way to go. By default, Docker uses a builder that only supports your local architecture. You need to build a new one. Docker build x create name multi-architecture builder, USE does something, and starts the builder and confirms supported platforms. Okay, let's create a builder X. Exit from this, exit, build X, help, create to create a new one, and options are name. We can to give it a name. There is no name. And USE. Build X. Multi-architecture builder. Let's call it multi-build. And USE means something. Unknown flag name. Yep, name does not exist. Let's just wait. We have to also say create. Wait, we can also ask for help after create. Create help. Cool. After this, we can name this, and USE set the current builder instance. Okay. Build X, create, name is multi-build, and use this as the current builder. Okay. Then we have our Dockerfile, and then we just create Docker build X, build platforms. These are the platforms. Tag, we will not push. Push is all architecture plus images created. Okay. Build X, build platform, Linux, AMD 64 slash, and Mac OS Linux ARM 64, Linux ARM v7, and yeah, we don't need anything else apart from this. We have given the platform tag is going to be 137 slash DSS. Cool. And then push to also push this, and dot shit BUILDX requires one argument. What did you do? PLAT. Docker build X build help to see what do we need. Architecture, we need architecture, platform, build, and the syntax is path URL. Yep, this comes at the end. Linux AMD 64, and tag JANRAGGB 137 slash DSS. Tag, that was the tag. Push, and here. Okay, shit. Okay, there was some problem before, but now it is fixed. Cool. So this is working. This is working. This is building. We are getting a new ISO. or image. Building. Okay, it's just like still building. And we'll get another repository here. That would be cool. And then what do we do? This is for pushing an image, which we are doing here. Cool. And then docker push prints the upload status of an image layer by layer all at once. The upload is complete. Yes, all at once when the upload is complete. Okay, pushing layers, no, it shows the thing layer by layer. Pushing layers, we see pushing layers, not all as one. Publishing, okay. And then delete and pull. Let's delete our local copy of the image, then pull it back from Docker up. Just like with GitHub, the nice thing about having image in the cloud is that if something happens to your computer or you are working on another machine, you can just pull it always. Remove the machine locally, then pull, remove the image locally, then pull the image and then run it as we would do with GitHub. Cool. We are slowly pushing images. Slowly pushing images. Cool. Now what are tags? Slowly, what are tags? Let's publish a new version of our web application with Docker. A tag is label that you can assign to a specific version of the same image. Similar tag. Okay, I didn't know tags exist in GitHub, but okay. Okay, they do exist. Like the head tag is a tag in GitHub. Latest tag is the default. Okay, this is just crazy. Like there is some one specific person, whoever it is watching. Can you say hi or something? Because I'm getting creepy vibes. There's just one dude sitting and watching. Okay, there are two. There are two. Cool. My bad for calling you out. But thank you for being here. Okay, here. What are tags? The latest tag is the default tag that Docker uses when you don't specify one. It is convention to use latest for the most recent version of an image, but it's also common to include other tags, often semantic tags like this, which give us versions. Pretty good. Okay, tags help us. Okay, we have this installed. Tags help us to publish different versions of the same image. That thing is there. Cool. TSSS. Latest OS Linux. This is built for Linux. Okay, let's add more architectures to this Linux platform and we separate them with a comma. Yes, we do separate them with a comma. We separate them with a comma /Linux on ARM64, Mac OS on AMD 64 and Mac OS. But this will take time. This will take time to install all the Alpine version for all of these images, but okay, this one should be fine. ARM64. Shit. Darwin. I guess that is not how you say Mac OS. Cool. Everything else is pretty cool. This will take some time to build, and right now we can see this. We have an image which is supported for Linux. Cool. Less than 1 day ago. Image management tags. Filter and apply. Deletion. Wait, shit. operating system and architecture. Cool. Building and pushing. Now we are pushing to the same thing. Cool. Then we will pull this tags. Yep, we have this for Linux AMD 64 machine and for Linux ARM 64 machine. Cool. Now we will SSH documents VPS secret admin walrus.codes port number 432 and cd docker sudo I, because yes, as the root user, and docker pull 137/ts. This is pulling the image, which is pretty cool. We have the image docker image ls. We have two images. Read docker image remove tui docker image ls docker run not in detached mode, in the main mode. Name, let's say ts. The name of the image for this, it is 137/ts. Cool. And we do see hello via bun. Cool. Docker image rm latest shit docker esa docker rm yes. Cool. We have removed the image. Cool. So that is how we create image and we upload the image to Docker Hub. Pretty cool. Tags for differentiating between versions of the same image. Publishing a new version of Docker image is very common method of deploying cloud native back-end servers. Okay, here is a diagram describing the deployment pipeline of many production systems, including the server that powers the boot up. Okay. What happens is code, whenever we make a commit, we get the new code. It is compiled into an executable. Docker image is built with all the dependencies. We make an image, put it on Docker Hub, which is pulled by the servers, production servers. Cool. And they run that image. Makes sense. And in this we change, we add a new tag and we upload the thing with the different tag. Docker image ls docker push. We need to build a different image. Build it. Let's say tag for this would be 0.03, let's say, and then we will push this, pushing layers. Pushed, all the layers have been pushed. Refresh. We have two different tags, latest and this one, which he just uploaded. Cool. And now latest is the default tag. If you look closely, you will notice that your old version is tagged latest. That is a bit confusing, as it turns out the latest tag doesn't always indicate latest tag doesn't always indicate that a special tag is the latest version of an image. In reality, latest is just a default tag that is used if you don't explicitly supply one. We didn't use a tag on the first version, that's why it is branded with the name latest. Okay. Should I use latest? I guess the convention I am familiar with is semantic versioning, like this. This build it with the very specific tag on your images, but also push the latest tag on your most recent image. That way you can keep all your old versions around, but the latest tag is still pointing to the latest image. Build the image. Okay, give multiple tags. Okay, shit, makes sense. Give multiple tags to the image and upload this image with all the new tags. That is pretty cool. And which is the best practicing of tagging, having two tags for the same image. Tag all new images with their versions numbered. Override the latest tag. That is the correct one. Seems like the correct one. Tag all new images with their version number. Tag all new images with the latest tag. Don't use tags now. Therefore, noobs who probably don't even use them. Well, yep, noob don't use them. And the bigger picture, this is like the last thing in the whole Docker part. Cool. This is the last lesson, but before we go, I want to reiterate how Docker fits into the software development cycle, particularly at modern DevOps tech companies, because it is really important to understand. Okay, the whole process is like this. You developer write some new code. Okay, the developer commits the code to Git. Makes sense. The developer pushes a new branch to GitHub, a new branch. Okay, a new branch. Okay, the developer opens a pull request to the main branch. Okay, we open a pull request. Then a team mate reviews the PR and approves. If it looks good, okay, the developer merges the pull request with the main branch. Okay, upon merging, an automated script, perhaps a GitHub action, is started. CI/CD. The script builds the code. If it is a compiled language, the script builds a new Docker image with the latest program. Okay, in the CI/CD pipeline, we get the latest code, we build an image. Out of that, the script pushes the new image to Docker Hub. Okay. The server that runs the containers, perhaps a Kubernetes. Okay, we don't know about Kubernetes. I don't know about Kubernetes. Cluster is told that there is a new version. Do not stop using the old image. Use the latest image. So the Kubernetes cluster shuts down old containers as it spins up new containers of the latest image. Cool. And now the same while the deployment process I have outlined above is a common one, especially at newer cloud native companies. Two companies rarely have identical processes. Instead of GitHub, it might be GitLab. Instead of Dockerhub, it might be ECR. Instead of Kubernetes, it might be Docker Swarm or more managed service. That's it. I hope this helps. Gives you give you an idea of what to expect in the wild. Okay, cool. So cool. We now know. I guess I've done 3 or 4 streams on Docker, and before that we had no idea what is Docker. Like, we have very little idea of what Docker does and what it is, but now we know that there are images, containers. You can spin up multiple containers from the same image. Then there are Docker files to create image. There is Docker Hub to push your new latest images, and yeah, there is Docker pull to get the new image and spin up the new server. Let's watch this video.
Docker is used for all sorts of things, but I want to quickly...
I guess that was a bit too loud. Wait,
run through how it's often specifically used in the deployment pipelines for web applications. Now, what I'm going to show you isn't how it's done in every single company out there, but most modern companies using Docker to deploy web apps do something like this. At least in my experience. We use Docker and Kubernetes for our backend here at boot.dev, so I'm actually giving you a real world example. This is what we do. Step 1 is to write or update the application code. We use Go here at boot.dev, but it obviously doesn't matter. You can write your app in whatever programming language you want. Step 2 is to commit the code to Git. Step 3 is to push the commit up to your shared version control host. This might be GitHub, for example, or GitLab. And then to open a pull request to merge your new change into the production branch. Step 4 is to merge the pull request, so your changes are now in the production branch. At boot.dev, we use main for production, but there's lots of conventions here. Step 5, and ideally this is automated, but it doesn't have to be, a new Docker image is built from the latest commit on the production branch. And step 6, the new image is pushed to a container registry. This could be Docker Hub, Google Artifact Registry, or AWS Elastic Container Registry. Step 7, your production environment, whether it's a VM, a Kubernetes cluster, or just an old computer running in your closet, well, it pulls down that new image and starts a new container from it. And then it shuts down any containers that were running older versions of the image. Again, this process won't be the same at every company, but it's a solid set of basic steps for getting your Dockerized application running in production.
That makes sense. And cool. So we have done Docker, I guess. At least we can start working with Docker. We can build our own images, and cool. Now the next thing would be in this Docker is done. I don't want to do this just yet. Grafana, which is used for observing data and stuff. AWS, no, Kubernetes would be next. Kubernetes would be next, and yep, that would be it. For today, that would be it. And we did Docker. Cool. And thank you for being here. Bye.